Greetings everyone. In today's video, we will learn the complete laboratory procedure for determining the unconfined compressive strength of soil. This test is widely used in geotechnical engineering to determine the shear strength of cohesive soils under unconfined conditions. In this demonstration, we have prepared a special mixture of soil, bentonite, sand and industrial waste material. Before preparing the UCS specimen, we must know the optimum moisture content and maximum dry density of the soil mixture. And these values are usually determined from the standard Proctor test. So, weight of the dry soil is equal to the multiplication of MDD of soil and volume of the mold. Weight of water can be calculated from optimum moisture content, which is equal to OMC by 100 into weight of dry soil, that will give the weight of water. Now once all the soil mixes will be taken, so mix it thoroughly as it can be seen in this figure. So once all the material is decided and its proportion is decided, so mix it. So these are the tools which will be used for UCS test. So first just mix the dry sample uniformly such that all the mixes, all the different mixes will achieve a homogeneous materials or homogeneous mix. Now after this dry mixing, add the water and do not add all the water at a time. Just add water in a phase wise and just mix the soil sample and water thoroughly and mix it such that all the soil sample will take part in this mixing. No soil and no water should harm in any manner. So here it can be seen. So all the soil sample and water is mixing in a proper manner. So here adding all the water in the mixes. So once all the water is mixed, it will achieve the maximum dry density. So mix them thoroughly until a uniform color and consistency are achieved. Now just we have to put this soil sample in a mold, and this UCS mold has a diameter of 38 mm and height of 76 mm. First apply a thin layer of lubricating oil inside the mold for easy extraction of the sample later. If this lubricant oil will be not applied inside the mold, then soil will extract in a proper manner. The soil may stick with the inside of the this mold. Now we start placing the moist soil into the mold in layer wise. Generally we put it in 3 layers for proper compaction. Just applied the required compactive energy to achieve the maximum dry density. So once the first layer is compacted, then second layer of soil will be placed in this mold. But before placement of next layer or before placing the next layer, scratch the previous layer thoroughly so that the next layer will form a proper bonding with the previous layer. If this scratch will not be done, then there will be not a proper bonding and there will be formation of layers between the inside the soil sample. Now the second layer of soil is placed, which is compacted. Now after proper compaction, the third layer of soil will be placed inside the soil sample. Now again just scratch the previous layer thoroughly. Once this layer is scratched, then we place the last and the final layer or third layer. But before do not place the third layer directly. Before placement of the third layer, just place a collar on the mold As we do it in the compaction test, CBR test, we place a collar for third or for the final layer compaction. Similarly here we placed a collar and then place the soil, then compact it for the final layer or for the third layer. Now it is compacted here. Once the layer is compacted, then remove the collar gently, and here if extra soil will be there, then remove it carefully, such that the mold will not be disturbed or the soil mold will not be disturbed. And if there will be less soil, then place extra soil, just like here, just place extra soil and compact it and make a proper mold of diameter 38 mm and height 76 mm. Just again, if extra soil is there, just a scratch or remove the extra soil. This remove the extra soil from both the side of the mold, from top and bottom also. Once the soil mold is compacted in this mold, it is placed in the soil sample extruder for extruding or for removing this soil sample from the mold. Carefully extract the specimen from the mold using a sample extruder. Here, this is a universal soil sample extruder, and place the mold here, and manually it can be just removed. The soil sample will be removed in a proper shape and size as of mold, that is 38 mm diameter and 76 mm height. Here it can be seen a soil sample in a proper dimension or proper shape can be removed through soil sample extruder. Now once the soil sample is extracted, just take its weight, and it should be very close to the calculated weight as earlier. A significant difference is found, then it indicates the improper compaction. Now place the specimen carefully on the lower platen of the UCS testing machine and set the proving ring dial and deformation dial gauge reading to 0. Now start giving the load from the top. Just switch on the UCS machine. Now this mold is subjected to load, and here there will be deflection. So we just measure the load for each 25 mm deflection, as here for each 25 mm deflection the load will be taken and will be noted, and it will be taken until the soil sample fails. So, and the soil sample failure will be known if this needle in the proving ring will start decreasing. As it can be shown, it is decreasing. Now it means the soil sample has been failed, or also the failure pattern can be easily seen in the soil sample. So, and the peak stress can be found by maximum load divided by cross sectional area of the specimen. I hope you found this step by step procedure helpful. So like, share and subscribe for more civil engineering lab videos. A special thanks to Amit, Priyanshu, Sahil and Devasis for conducting this experimental and preparing these videos. Thank you for watching. Jai Hind.